Hi everyone. So now we are going to talk about basic properties of magnets. Okay. So the magnets have different properties. So like there's different terminologies are there. So while we discussed when we discussed about charges, we have discussed some of the terminologies like electric field, or something related to charges, dipole moment, etc., etc. All those things we have discussed, right? So similarly, when we talk about magnets, we have to talk about their properties and terminologies about magnet. Okay. So first of all, we are going to discuss magnetic dipole moment, or simply we call it as magnetic moment. Okay. It is nothing but, so do you remember what was electric dipole moment? So when there was two charges and plus q and minus q, and there will be a dipole moment between them. Okay, so that was electric dipole moment. Magnetic dipole moment, when you consider a bar magnet has south pole and north pole. So two equal pole strength, I will discuss what is pole strength. Two equal pole strength at a distance. So that was in the case of, and similarly you can easily connect it with electric dipole, right? Yeah. So now listen. So here one bar magnet is there. So this is the north pole and this is the south pole. Okay. And the QM, what is QM? QM is nothing but, it is nothing but its pole strength. Pole strength. Okay. What is pole strength? In a charge, you might have noticed that we have a quantity of that charge, that is the amount of charge, right? So we can simply call it as it is a charge, or you can consider it as there is a quantity behind that charge, that is the amount of charge. Similarly, here the pole, each pole have pole strength. So we have equal and opposite charges we had discussed. Similarly, here we have south pole and north pole, equal pole strength, and the pole strength we represent by Qm. In some books, they denote pole strength by the letter P. Okay. So now, all of you listen. This magnetic dipole moment we represent by the letter P, which is nothing but charge into the length. What is that? What is this length? Do you remember what was electric dipole moment? Q into 2L. Here we are going to discuss, this was a vector quantity. Q is not a vector, right? L was a vector. So similarly, here we are denoting, here we are denoting that 2L by the letter, all of you listen, Qm into D. So this is what is this D? This D is a vector, or this D is also known as magnetic length. Magnetic length. What is magnetic length? Which is a vector quantity, which is actually the length 2L, the magnitude is equal to 2L, and the direction is from south to north. In this direction, south to north. So that is what is this magnetic length. And what is the magnitude of magnetic length D? Which is nothing but 2L. So you can also write magnetic moment P is equal to, or the magnitude of that is equal to Qm into 2L. This is what is magnetic dipole moment or magnetic moment. So what is magnetic moment? It is nothing but, it is a product of pole strength into the vector starting from south to north, that is a length vector, or this 2L vector. This is, we represent the 2L is the magnitude, direction is from south to north. So my question is, what would be the direction of magnetic moment? It is also from south to north. I think you have got it, right? Yeah. So now, all of you listen, what is the unit of magnetic moment? Ampere meter square. Unit is ampere meter square. So this is all about magnetic dipole moment or magnetic moment. Next is magnetic field. What is a magnetic field? So what was electric field when there is a charge over there, so there would be a region, there would be a space around that charge where there is another point charge would feel or would experience a force due to that charge. So similarly, magnetic field is nothing but it is a region around. Suppose there is a magnet over here, and suppose this is south and north, and we know that single pole never exists. So this one, there will be a field around this region where there is another magnet or another magnetic material would experience a force. It could be attraction or repulsion, but there would be a force. So that is what is magnetic field. So magnetic field and electric field you can define in that way, where there is another magnetic material or a magnet would feel a force or would experience a force. Okay. So magnetic field also I can define it as magnetic field. I can define it as magnetic field is nothing but the force experienced by the other magnet divided by pole strength, or the force divided by or force per magnetic pole strength, magnetic pole strength. So what is magnetic field? It is nothing but the force per magnetic pole strength. So this is what is magnetic field. So you got two explanation or two definitions of magnetic field, and you have the idea of magnetic field. If someone is asking you that what is exactly magnetic field, then only you have to explain it this way. And what is the unit of this one? Newton, ampere raised to -1, meter raised to -1. Okay, so this is what is the unit of magnetic field. Okay, and this is also known as Tesla. What is that? Tesla. Okay, after the great scientist Nikola Tesla. So this is what is about magnetic dipole moment or magnetic moment and magnetic field. And further properties or terminologies we will discuss in the next session.